Hello. So today we are going to talk about exponent rules. Majority of what we go over today is going to be like review from what you learned in Math 1 and Math 2. But it's just important to make sure that we really have these rules down because when you enter into Math 3, especially Honors Math 3, it's assumed that you remember these, you feel comfortable with them, and you're able to kind of apply these rules. All right. So what I want you to do is on that blank page in your packet, go ahead and pause this video and copy down all of these rules. These are exponent rules that you're going to want to have memorized and know how to use. And what I'll do is as we're going through the video, I'll kind of refer back to these as we work through it. So pause and copy it down. Alrighty, so these first few hopefully are like super duper easy. So number one here, this is multiplying things with exponents, right? So that would be the product rule. When we multiply things with exponents, you add the powers, right? The base stays the same, you add the power. So this guy here would be a to the 9th. All right. Now the next one here, this is when you raise a power to a power. So if we look here, the power rule, when you raise a power to a power, you multiply the powers. So here, this is going to become z to the 15th. All right. Now, when you are multiplying powers, one thing to keep in mind is if there is no power there, it's assumed that it is a power of 1, right? So t to the 3rd times t to the 1st is going to be t to the 4th. Add them. All right, so hopefully we feel pretty good with those. You'll notice a lot of these I'm going to kind of skip through just for the sake of time. All right, so this is another multiplication one. Now, when you're doing multiplication, these coefficients you just multiply, okay? So 4 times 9 is going to give us 36. And then when we multiply our exponents again, when you multiply exponents, you add the power. So it's going to be 36 q to the 7th. All right. Let's see. We'll do this one. So similar thing here, we multiply the powers out in front. And this is going to give me a 18. Negative times a negative gives me a positive. And then we go ahead and we multiply the powers, which by doing that we add, and we end up with s to the 8th. All right, so this next one, number 10, we have to use the power of a product rule, okay? So if you have two things that are being multiplied and raised to a power, you essentially have to distribute that power to everything, okay? Now, one thing I want to point out is this rule only applies when things are being multiplied on the inside. If you have two things being added, you cannot distribute that. That does not work, okay? And we'll do problems like that later. But you can only distribute the power like this when things are being multiplied on the inside. All right. So here, we would distribute this power of 3. Now, one thing to keep in mind, you want to make sure that when you raise actual coefficients, numbers to powers, that you put parentheses around those values. Now, when is this going to matter? When you raise a negative to a even number, that's going to make it positive. All right. So if you don't use those parentheses, it's going to mark it wrong because it doesn't change the sign. So negative 7 to the power of 3, we end up with negative 343. And then s to the 3rd. All right. Let's try something like this. All right, so we multiply the coefficients. If there's no coefficient, it's implied to be 1, right? So we get 10 times 1, which is 10. X cubed times x squared. Multiply powers, you add them, you get x to the 5th. And the y doesn't have anyone to multiply with, so he just stays the same. All right. Similar situation here. You multiply the coefficients out in front. So 16 times 9 is going to give me 144. And I'm going to get y, or I'm sorry, x to the 7th and y to the 6th. Alrighty. Let's go try. What would be good ones here? All right, let's try this one. All right, so again, we want to make sure, this one we're going to use that, let's see, what was that called again? The power of a product rule. All right, so we have things being multiplied, raised to a power here. Now, if you recall, remember I told you that you have to make sure that negative numbers, when you raise them to powers, you put them in parentheses. All right. So we get negative 5 squared, which is going to give us a positive 25. All right. And we get x to the 4th squared. It's going to, when you raise power to a power, you multiply, you get x to the 8th. And then we get y to the 4th. All right. All right, let's go ahead and take a look here at 22. So far, we've covered quite a few of these. It actually would probably help if I did this. Let's see. Oop, nope. There we go. We could leave that up and refer back to it. All right, so far we've gone through product rule, power rule, and power of a product. Now we're going to talk about quotient rule, okay? So with quotient rule, that's when you're dividing things with powers. And when you divide things, you do top minus bottom, all right? So what we're going to do is we've got these numbers out in front here. We're going to simplify these. You can simplify it in your head. It's like simplifying a fraction, really. If you need to use your calculator, that's totally fine. You're just going to do 21 divided by 35. And then you're going to want to switch that back into a fraction. So we end up with 3/5. All right. And then top minus bottom, we end up with x to the power of 0. And top minus bottom here, we end up with y squared. Now, another property of exponents here is the 0 exponent. Anything raised to the power of 0 is equal to 1. Now, since that's being multiplied, the 1's kind of just going to go away, right? When you multiply anything by 1, it's just itself. So the way that I would recommend writing your final answer here is that x to the 0 is kind of going to go away, and anything with positive powers goes on top of the fraction, and anything with negative powers goes on the bottom. And we'll talk about that as we get to some of those. All right, next one here. So we've got 24 divided by 8. That is going to give us a 3. Oop, sorry. I think I have another alarm set for 55, so we'll turn that off. All right, then we're going to do top minus bottom. We get x to the negative 1, and we get y squared, top minus bottom. Now, another property is negative exponents. So, when you have negative exponents, so one thing to keep in mind is if it starts in the numerator, it would get moved to the denominator, change signs. If it starts in the denominator, it gets moved to the numerator, change signs. So here, right, we have negative exponents. It's going to get booted down to the denominator there. So we end up with 3y squared. The y is going to go on top because it's positive. The x is negative, so he goes on the bottom. All right. Let's see. I'd like some more negative ones. All right, let's try this guy out here. So we're going to simplify these guys here. 2 divided by 4 is going to become 1/2. We end up with x to the negative 2, y to the 3. So again, the negative exponents are going to get booted down to the bottom. So we end up with a 1 on top and a y to the 3rd on top and a 2 on the bottom and an x squared on the bottom. Now, when you already have stuff in the numerator, we know that like 1 times y to the 3rd is just going to be y to the 3rd. So kind of the more mathy way to write that would be, it's like, you know how you don't write 1x, you just write x. Same thing here. And we get that. All right. Let's see. Okay, so for these two, I'm going to, this one's kind of a review of when we just did earlier in the video, but I want to make sure we contrast that with this guy here. So let's go ahead. We're going to apply the power of a product rule here. Everything on the inside is being multiplied, so we can just distribute that power. Now, remember, when we have a negative, we have to make sure we remember to put that in parentheses. Negative 2 squared is going to give us a positive 4. And keep in mind, when there's no exponent there, it's an implied 1. So 2 times 1 gives us 2. And we're going to get y to the 6. Remember, when you raise a power to a power, you multiply. All right. Now, 29 is different. Okay. And it's different because the things on the inside are not being multiplied. They're being subtracted. So if things on the inside are being added or subtracted, you can't just distribute that power. It's very important that you remember that. So when that happens, what you have to do is write this twice. Well, because it's being squared, right? And actually FOIL this out, okay? I mean, this one, in reality, you technically are writing this one twice, right? Like, if you have negative 2x y to the third times negative 2x y to the third, right? Negative 2 times negative 2 gives us 4. X times x is x squared. And y to the third times y to the third is going to give us y to the 6, right? So that's really what you're doing up there, but because it's all being multiplied, you can just distribute the 2. You cannot do that here, so you have to literally write the what's inside of the parentheses twice and FOIL this out, all right? So we do 4x to the 4th times 4x to the 4th. That's going to give us 16x to the 8th. And then we get negative 4x to the 4th. Y. Negative 4x to the 4th. Y. And positive y, because it's negative 1 times negative 1 squared. These guys are like terms, so we can combine them. So our final answer here is going to be 16x to the 8th minus 8x to the 4th y plus y squared. Now remember, when you are combining like terms, you don't add the powers. A lot of people would be tempted here to add these powers. You only add powers when you're multiplying. When you're combining like terms, the powers stay the same. All right. Okay. Let's try this one. So we're going to go ahead. Oops. 125 divided by 5 here is going to give us 25. X squared divided by x is going to give us just x. And y to the third divided by y to the 7th is going to give us y to the negative 4. So when we simplify this and write this with only positive exponents, we end up with a 25. The x stays on top because he has a positive, but the y is going to get booted down to the bottom. Alrighty. Okay, so number 31. There's no coefficient, so there's nothing to, simplify out in front. X to the 8th divided by x to the 8th is going to give us x to the power of 0. And then y squared divided by y to the 5th is going to give us y to the negative 3. All right, so x to the 0 is just 1. So really that's equal to just y to the negative 3. Now, we have to boot this guy down to the denominator. Okay, now the way this problem is slightly different than what we've been dealing with is, well, there's nothing left in the numerator, right? He gets booted down. There's nothing left up there. When that happens, you have to put a 1. All right, so if everything gets booted down, you have to leave a 1 in the numerator. Alrighty, next one here. Okay, so problems like these where there's negatives when there's negative exponents to begin with. There's a couple of different ways to go about this. You could just do top minus bottom and subtract a negative, which ends up adding it. But honestly, what I have found to be just kind of a lot easier in simplifying these guys is if it's negative, change its level and make it positive, right? So like if we have a negative in the denominator, he's going to get booted up. So we have x squared, x squared y, and this guy gets booted up, and he's now in the numerator with a positive 4. Then we just simplify this. We get x to the 4th, y to the 5th. All right, let's try this same thing here. I like to rewrite this so that there's no negative exponents right at the beginning. So I end up with x, y to the 8th, y to the 5th, x to the 6th. Now we can simplify our top here. These guys are just being multiplied, so we add them. So we get y to the 13th. And then we've got our x to the 6th on the bottom. Now we got to divide those. So top minus bottom, that's like 1. So we get x to the negative 5th, y to the 13th. Can't leave those negative exponents in there. So we've got y to the 13th over x to the 5th. Alrighty. Okay. Now, this guy here. Here we would apply the power of a product rule again, where we essentially just like distribute this. All right. So we have negative 2 to the negative 1 and x to the negative 1. All right. There's a couple of different ways you could go about this. Honestly, what I would recommend doing, remember how I said if you have a negative exponent, just change its level and make it positive, right? So both of them have to get booted down to the denominator here. So we get negative 2 to the power of 1 and x to the power of 1, which when you simplify that, it's just 1 over negative 2x. All right. Now here, this one is similar but different, right? Because this negative 3, it only applies to the x because there's no parentheses here, okay? So when we simplify this, the negative 4 is the same. It stays on top because he doesn't have a negative exponent. But the x to the 3rd gets booted down because he has a negative exponent. All right. Next one here. So let's go ahead. We are going to apply the power, or not the power, well, we're going to apply the power of a product rule and the power rule really at the same time. So on top, we end up with 4 to the 3rd, and then we get w to the power of 6. And then this is 20 and w to the 5th. So I would simplify this. 4 to the power of 3 is 64. So you have 64, w to the 6th, all over 20, w to the 5th. 64 divided by 20 simplifies to 16/5. Top minus bottom gives us just w to the 1st power, which that means it's positive. It's going to go in the numerator, so we get 16w all over 5. All right, and we'll try this guy. So this 4 only applies to the d to the 3rd. It doesn't get distributed to the 3 because the 3 is not inside the parentheses. So we end up with 3d to the 12th all over 6d to the 7th. This simplifies to 1/2. And then we have d to the, let's see, d to the 5th. That's positive, so we have like 1 times d to the 5th all over 2, which, like I said, that 1 doesn't really need to be there, so it would be d to the 5th over 2. All right, I think that's enough for one video.